Hello everyone, and thanks to the Committee of Whispers for giving me the opportunity to present my work, which focuses on the identification of vineyard water status from VNIR-SWIR hyperspectral measurements. I'm in the last year of my PhD with the company Terranis and the laboratory VNIR-SWIR of Purpan and INRAE. Part of the work presented here has been published in remote sensing. Whereas wine needs moderate water constraints to ensure the quality of the produced wine, in the context of climate change, the increase of drought events, heat, and the lack of water leads to a serious loss of quality and productivity in most of the vine regions, as in the Mediterranean regions where this study was conducted. So there is a need to find the water resource management decision tools, and monitoring vine water status using remote sensing data can be a key for the future. So my PhD focuses on two objectives. The first presented today and already published to identify interesting spectral domain with hyperspectral measurements, and a second one in process of publication about the potentiality of satellite imagery for an operational commercial service. So we set up an experiment to make a link between physical impact of water stress on the plant and leaf the reflectance values. Two types of measurements were occurred in 4 vine plots every 2 weeks from July to August in 2019. The first one is the water status with the stem water potential, which is an accurate but time-consuming method. Value range from 0 for no stress to -2 for high water stress. And the second measurement is a hyperspectral reflectance of leaves and canopy with an ISD field spectrum. Analyses have been carried out using the raw spectrum, considering each wavelength apart, or with wavelength combination with hyperspectral vegetation indices. In the second time, we also averaged the spectrum by spectral domain, and also use domain combination with multispectral vegetation indices. These 4 features were then analyzed with 2 models, a simple linear regression and a non-linear regression models, the extra trees. Because of the low number of samples, there is an important risk of overfitting, so the objective was not to find the best fit between hyperspectral measurements and SWP values, but rather to highlight the most promising wavelengths and spectral domains. In terms of results, you can find all the details in the publication, but here are some significant results with the raw wavelengths. The wavelength importance based on the Gini index for SWP prediction with extra tree regressor model, and the determination coefficient between SWP value and the NDSI with linear models. The first highlighted wavelengths are located in the SWIR region, the second in the reddish region, and NIR region was also highlighted with domains analysis. Several hyper and multispectral indices have also been highlighted. The perspective of this work leads to the second axis of my PhD to verify the potentiality of satellite imagery. And in order to do so, several satellite sensors have been simulated with our hyperspectral data to mimic their spectral bands. And these simulated data were used to predict the SWP values. The results give promising perspectives with Worldview 3, but considering the price and the time of visits, investigate the use of Sentinel-2 could be more reasonable. So in the current part of our study, we are using real Sentinel-2 images with infill data from 3 years. A model with 4 spectral bands gives interesting results to predict SWP value with scores greater to what we had with the simulated data. And even if the model scores are not so high, we are working with several vine growers in Minerva region to verify the spatial and temporal coherence, giving them a water status map like this one for several dates, and their first feedbacks are really promising to keep on with our study. Thank you for listening.